Flood control is a critical aspect of managing water overflow from rivers and streams, and it's vital for protecting lives, property, and the environment. When we think about flooding, we often picture the devastating impact it can have: homes destroyed, communities displaced, and ecosystems disrupted. To tackle this challenge, we have a variety of methods at our disposal, which can be broadly categorized into structural and non-structural approaches. Let's start with structural methods. Dams are one of the most prominent tools in our flood control arsenal. These massive structures regulate water flow, storing excess water during heavy rainfall and releasing it gradually. While they can significantly reduce flood risks, we must also consider their environmental impact, as they can alter ecosystems and even displace communities. Then we have levees, embankments built along riverbanks to keep floodwaters at bay. They can be made from earth or other materials and can be either permanent or temporary. Some levees are deployable barriers ready to spring into action during emergencies. Flood walls, on the other hand, are solid barriers made of concrete or steel, strategically placed to protect vulnerable areas. They're effective but can be costly and may change the landscape's aesthetics. Flood control reservoirs are another essential method. These reservoirs store excess stormwater and release it later, helping to reduce peak discharge. They can also serve multiple purposes, like providing recreational opportunities or generating hydropower. Channel alterations, which involve modifying river channels, can help lower water levels at specific points, but we must be cautious as this can raise water levels downstream. Tidal barriers are particularly useful for coastal regions, preventing high tides from flooding inland areas. Dredging, the process of removing sediment and debris from waterways, increases capacity and improves drainage, but it requires careful execution to avoid harming local ecosystems. Now, let's shift gears to non-structural methods. Zoning laws play a crucial role in managing land use in flood-prone areas, helping to minimize property damage and loss of life. Implementing these laws can restrict development in high-risk zones, making a significant difference when floods hit. Early warning systems are another vital tool. They use technology to predict floods and alert communities, allowing for timely evacuations and preparations. This proactive approach is essential for minimizing damage and ensuring public safety. Floodplain management focuses on preserving and restoring natural floodplains, which can absorb excess water and act as buffers against floodwaters. This method emphasizes sustainable land use and the health of our ecosystems. Community engagement is key to effective flood management. Involving local communities in planning can enhance resilience and lead to more accepted flood control measures. The applications of these flood control methods are vast. In urban areas, they're integrated into drainage systems and embankments to manage stormwater effectively. For agriculture, these measures protect farmland from inundation, ensuring food security and economic stability. They also safeguard critical infrastructure like roads and utilities, maintaining essential services during and after flood events. Ultimately, effective flood control requires a blend of structural and non-structural methods tailored to local conditions and community needs. As climate change continues to increase the frequency and intensity of flooding events, innovative strategies will be essential for safeguarding lives, property, and our precious ecosystems.